Good evening and welcome to our WebTalk, AI in Data Literacy and Education, Empowerment Without the Buzz. I'm Cin Pietschmann from the German Informatics Society and I will be your host tonight. My dear colleague Elisabeth Schaumann will be our tech support so everything runs smoothly. Thank you very much, Elisabeth. AI has become such a big topic within the last couple of years. Everybody is talking about it. It has become such a buzzword, but at the same time, people often don't really know what artificial intelligence really is, and that we already have it every day in our life. So I think it makes a lot of sense to further AI education on that. At our project TrainDL, we aim to identify how data literacy and competences on artificial intelligence can be implemented into teacher trainings in order to reduce the digital gap and get people educated. We also create recommendations based on our findings for stakeholders and policymakers across Europe. But we also want to look at the topic a little bit more in depth and from different sides and perspective and create a dialogue with experts all over Europe. So I'm looking forward that we're starting that now with this web talk and discuss the topic of empowerment and education with 3 excellent experts. So let's get started. How we can create empowerment without the buzz and the hype. Let me introduce our experts. First, she's the leader of the German Informatics Society Task Force AI in Education, and for a very good reason. She teaches and researches for over 15 years on the topic of AI, machine learning, and cognitive modeling, as well as being a professor for cognitive systems at the Bamberg University. Welcome to the Web Talk, Professor Dr. Ute Schmid.
Hello, thanks for the invitation.
Yes, greatly appreciated you being here. Thank you very much. Going further, another expert works at the State Institute for School Development of the German state of Baden-Württemberg and is responsible for shaping and further developing the content of its computer science education plans. A warm welcome to Alexander Mittag.
Thank you very much. And well, thank you very much for the invitation. It's great to be here.
Thank you for being here. And to round up our round of experts with the degrees in new media design and musicology, she's a technology educator who's both interested in formal and informal learning settings and leads the development team of the online course Elements of AI at University of Helsinki. A big welcome from Germany to Finland for Sanna Reponen.
Guten Abend, nice to be here.
Hyvä. Thank you so much for taking your time being here. And before I start our round of questions for the experts, I have questions for our audience. And there should pop up 2 questions. One question is, do you think the topic of AI is overhyped? And the second question is, do you think AI can be used in a meaningful way in the education to empower people? We will look at the results later on, and I would get with my first question to Ms. Schmid. And I really would like to know, you have worked for over 15 years in the field of AI, so you got a lot of expertise. And looking back, but also looking forward with this knowledge and expertise, are we heading in the right direction regarding AI and data literacy in education? Is there something we are still clearly missing?
I think definitely. So we all know, I think, that AI has not only its summers, but also its winters. But I think together with the digital transformation we are experiencing, which will not go away anymore, for sure, there is definitely will be there more and more application of AI, especially machine learning, in various domains. So I think then we want to stay a democratic society. Everybody should at least have a basic understanding of what AI methods are, what AI can do, and maybe that the big danger is not that the Terminator is coming around, a superhuman intelligence, but the danger is, we see it currently with the Facebook things in the news. I think the dangers are how easily we give our data and how companies use them. This, I think, is one of the big topics. And so I think education in AI and data science, data literacy is elementary to keep everybody on board for how the future will develop.
Thank you very much. My next question would be at Mrs. Reponen. And I would like to know, you're working on the online course Elements of AI, and it's aimed specifically at youth. What is your approach to developing the content, and what are, in your eyes, important points to take into account here?
Elements of AI is used a lot in, for example, secondary education and also in higher education. But it's actually the age distribution is really nice. It spans from, let's say, 15 to 75, 80 years. So it's not only for youth, but with the 760,000 registered users, I'd say it's not easy to design for all, but somehow it looks like it's going all right. But anyway, our design principles consist of, okay, first of all, we need to tackle those exact points that Mrs. Schmid addressed. Everybody has the right for the basic understanding. And our approach is creating a balance of what science and industry have to say about these things. So it's created by University of Helsinki and Reactor, which is a digital consultancy. And we want it to be the friendliest and the most respectful course on AI that there is. So we don't require anyone to know math or coding, but we want to speak we want to keep it conversational. So that I think in short describes our approach.
Thank you. Just to make sure, was the course in the beginning designed for young people, and then in the end you saw that a lot of people wanted to use it? Or didn't I do good research and it was already for everybody aimed at from the start?
It's actually been for everybody from the very beginning, because there's a lot of people who need these skills in their everyday work and want to upskill a little bit. But as a result, we're now at University of Helsinki specifically looking at different projects where we will move forward with creating materials that work even better for young people and kids. So we are now starting in the beginning of 2022 a project together with several partners like University of Eastern Finland, a project where we will do learning materials and teacher training for teachers in primary schools in Finland, and possibly this will become an online course in the lines of Elements of AI at some point.
Thank you very much. I'm looking forward to the start of the project because it's definitely in line what we do at our project TrainDL. That's exciting. My next question would be addressing Mr. Mittag. You're working on computer science curricula for school education. And what difficulties do you encounter in implementing AI in data literacy into formal learning? Or do you encounter people who, for example, are completely against it and you have to work through that first?
Well, the problems are very specific for each state. I think, well, let's start with AI. And of course, AI is a great way to solve specific problems and opens possibilities that weren't possible before. But it's just one way to process data, as is, let's say, statistics, formulas, calculate an average of data. And the second way to process data is the way of doing it with programs, the classical algorithm loop. And the third way is a way doing it by use of AI. These are just three ways of processing data. And these three ways do have in common that they're all belong to the huge domain of computer science. Now, where's the problem of implementing AI in data literacy? In formal education, it's just, you could think, well, very often it's mentioned it's a problem. We don't have enough teachers who are educated, but there's actually one in the state of Baden-Württemberg, one limiting resource. And I just want to show you that if you have a look at the time, the lessons that are taught in school between grades 5 and 10, then there's a total of 185 lessons, English, German, whatever subject we have. And there's a nice pie chart, and maybe you can spot on this pie chart where is computer science. I might give you a little help. It's up there. It's not called computer science, we call it Informatik in Germany. And we have a total time of 0.5% from grade 5 to grade 7. And the big hope is, if we talk about the 21st century skills, what we want to put in there. Algorithms, big data, whatever. And of course, AI, data literacy. And if you look at the chart, I think the limiting factor is really clear. Of course, we encounter some problems in teacher training, but the limiting resource is just the time we have in school. We do have, according to that, we do have some lessons in grades 8 to 10 that are actually optional, but only about 10 to 15% of all students are to choose these subjects, can even choose these subjects. And of course, we do have in the K-12 education the last years, there are possibilities, but for the overall part of students between grades 5 and 10, it's one lesson out of 185.
Thank you very much. Also, the chart you shared illustrated very well how little space informatics or computer science actually takes in German schools. It's pretty sad. But thank you very much. Going further, I would have another question for Mrs. Schmid. And before you started studying, but also like teaching and researching in computer science, you studied psychology, as did I, by the way. So I'm very interested on your perspective from psychology on the topic of AI in education. Can we learn something from social science for implementing an AI in data literacy?
That's a good question and not an easy one. So my background in psychology has been mainly experimental cognitive psychology. Yeah. So I'm very interested, still are very interested in how humans learn, decide, perceive, plan, solve problems, and so on. Yeah. And when I look at the current developments, so I will a little bit digress, but not too far, I hope. When I look at the current developments of how you apply AI tools in school, the vision, at least what we want to do in Germany, I don't know about the discussion in Finland. What I heard is learning analytics. And learning analytics is a little bit, especially predictive analytics in the domain of education is a little bit like predictive maintenance for machines, and it's very behavioralistic in many accounts. And I think there might be helpful aspects, but doing this naively is very dangerous. And if teachers and researchers in education would understand better what deep learning can and what deep learning can't, yeah? And when you produce unwanted biases based on sampling biases mainly, and when you have no background in statistics and data science, you kind of see, some people see AI as now everything will good. We will have this AI in the classroom, yeah? And this will empower teachers and so on. Very nice, but very naive. I'm very much in favor of thinking about AI tools in school, but selected at specific points, justified by educational considerations, quality controlled and so on, and thinking about the social technical consequences. So data science is a topic in school. Yes, definitely important in two ways. First, educate the teachers about the use, also promises of AI and so on, to make them understand that. And second, of course, now I come, I think, to your question. Alexander Mittag on his slide had in this small bar all the things we want to teach in computer science, right? And I think computational thinking, coding, understanding a little bit about machine learning principles and so on is really important, yeah? Starting even in primary school. We have currently a course in the KI campus about data literacy and machine learning for primary school. I think this is important. Why? Because in a modern society, we don't need so much that students learn by heart. This is never a good idea. We need people who think, people who have competencies. And experience shows, it's only for me anecdotal experience, that students in school, primary and secondary education, for instance, get more relaxed when they make errors. At least in Bavaria, school is like, hide errors. Errors is something really terrible. At the moment, when you start writing programs, you know you make errors. And the good thing is to recognize them, to test your program, and you can correct them. And this error culture is, besides computational thinking and complex problem solving, again, important if you want to have a modern society and not educate parrots.
Thank you very much. You saying this also reminds me, in the past I worked at the, let's say, maker education for youth. And we also taught them on like debugging and error culture. And this was not something that was just relevant to computer science and making, but just for them as humans, because they learned that you can make errors and this is normal, and this is the progression of not only computer science, but of being human. So this is really a learning opportunity on so many levels. Mrs. Reponen, I think you want to say something to that.
Yeah, because this is one of my favorite topics. Thank you both, Mrs. Schmid and Mrs. Pietschmann, for this. Yes, what is like a hot topic in Finnish education? Well, I could talk about the slides and the percentages and everything, but this is what I want to tackle. Project-based learning. And the less hours you have, the better an idea it might be that what you have to teach about AI, machine learning, data literacy, it is experiential and possibly also something where students get to express what they feel is important or fun or beautiful. Because if they get to do something like express what they find interesting, then errors might be the source of something interesting as well. Errors don't matter because not everybody is not doing the same project. You're doing your own project, and it doesn't matter if there's skill differences necessarily, because those who have more skills produce a different outcome, and those who might not have enough skills might have a great idea. And if you can come up with a project that you then present to the others, it's the idea that you get the kudos for. And yeah, that's one way to tackle errors. And if you don't concentrate on things that you need to learn by heart, I second that as well. Well, those things, if you have such a small time to use in a classroom, do you remember those things that you had to learn by heart in that short time? No. But if you experience something that was meaningful and powerful for you, that might actually have an impact very much longer and so much later in your life. I did this. I remember I did this. I remember it had something to do with machine learning. I don't remember how I did it, but I did it and I could do it, and maybe I could do it again.
Thank you very much for that insight. Going from this two statements, I would have another question for Mr. Mittag. We just got presented with the proposition of AI as a project-based learning. How is that? Is it implemented in your educational plans? Is it something being discussed at your work? What is the status quo there?
Well, currently AI does not play a really major role in computer science. As in grades 5 to 10, there's just no time for this. I think if you want to have an understanding of AI, or to get the idea of AI, I think it's based on you have to know how a classical algorithm or basic things work. You can't just start with AI. I think one of the greatest dangers we have in AI in school education is the hope that you can skip all the classical computer science stuff, all the algorithm, the nerdy programming, and just by AI magic, you get to the top of some whatever, and you can't skip all the nerdy stuff. And this is not true. And if you do AI, that's like in mathematics. If you start doing calculus, you start doing integrals, you start doing statistics. Yeah, it's great, but first of all, you have to start with multiplication tables, addition of two numbers, and that's what we spend in primary school. We spend 4 years on all that. That doesn't come by just a movement of hands and by the belief in some magic. So we haven't encountered it yet, but we're currently thinking of implementing the idea of implementing some stuff in the higher grades, 11, 12, but it's implemented at the moment.
Thank you very much. Mrs. Schmid, you want to get in on that?
Yeah, so I completely agree that when you want to have a real understanding starting, that you need to start with basic computer science and mathematics before you progress. But I think the big challenge is, at least in Bavaria, I was invited for one expert meeting when in Bavaria it was decided to have computer science for all 11th graders. Some years ago, this discussion went on. Even in Bavaria or in Germany, we have the system that you can, in gymnasium, select a track, like a STEM track or a fine arts track and so on. So when you do in the 11th grade, let's say Google PageRank, or let's say a perceptron or a decision tree, yeah? Obviously, when you want to teach this, you need a background in mathematics. You might have already to have learned about how to deal with vectors. When you do decision trees, you even need algebraic data types. You need a tree data structure, which is not trivial. And many computer science students have problems with that in their first semesters. So I completely agree. But the challenge is you also have to teach this to high school students without this background, maybe not in computer science, but in ethics, in a class on social sciences. You have to teach adults with not academic background, at least so much that they don't give Facebook their data, I'm sorry. and so on and so on, right? Therefore, I think the big challenge is that we need a really good curriculum for AI in school based on informatics. And on the same hand, we need this AI for everybody. So elements of AI is, I think, a little bit in between. It's not, but we have in Germany, KI Campus, we adopted the elements of AI, but there is also something like AI in 5 minutes. Yeah, obviously. Yeah, come on. Yeah, whatever, brain surgery in 5 minutes will not really make you a brain surgeon, right? But I think we need to keep in mind all these different backgrounds and aims. And basically, everybody should have a little bit an understanding.
Thank you very much. I see another hand raised, wanting to get in on that, please. Really nice to hear that KI Campus has found use for elements of AI as well. About that like project-based and doing fun stuff and tricks with AI and the need for understanding the basics. I think this is where a great educator can shine. You can start with experimenting with tools like Google's Teachable Machine, which doesn't really explain at start what it is. But this is where the educator steps in. If you structure the lesson, like you do experiments, you try out, you explain what you managed to do and what you did not manage to do, and then start analyzing the different findings that you get from the classroom, and you work like reverse engineer and work backwards. I do believe that this holds like a lot of potential for actually grabbing those important basic things about AI, but it's done like experience first, hands-on, and if the educator knows their business, they truly will like tackle the right things and the right findings. But these black boxes, of course, aren't simple. If you use technologies that don't show their insides, then there's like great things about it and a little bit problematic things about it. ICT is so layered these days that in everyday work you use a lot of tools that like consist of layers, and you only get to use the UI of it, and then you call it AI. And you couldn't do these things without the layered ICT that we have today. But already the fact that in the classroom you can use a tool that does amazing things, and together with the students you scrape it a little bit and see like the next layer underneath, and maybe if you're lucky a couple of layers. That is already something that is relevant, I believe. Thank you very much. Getting in on that, you are now busy with the online course, which is, I would say, more an informal learning setting, but you also have a project ahead that's set in a formal education setting. What would you say are opportunities, but also obstacles for both settings?
In Finland we also have the obstacle of curriculum. It's sort of horrible to say that a curriculum is an obstacle, but it is true in Finland as well that there is quite a little time to dedicate to computer science as a whole. In Finland, the approach is that computer science is embedded in all other subjects. There are good things about this, and there are maybe negative sides to it as well, because this allows, in some cases, like different learning outcomes depending on whether the teacher is like an early adopter, a motivated and skilled person. If all the teachers are supposed to embed computer science in their teaching, it's really hard to avoid. And this is one obstacle that we are facing specifically.
Thank you very much. Then I would get more into the teacher's perspective with Mr. Mittag. So school education is obviously about pupils, but also teachers. So what do computer science teachers, but also non-computer science teachers actually thinking about teaching AI and data literacy? Is there maybe a perspective from teachers that should get more attention?
Yeah, well, thank you. It's a really good question because we have split up the two groups, teachers that teach computer science and teachers that do not teach computer science. And starting with the first group, I think the overall rating of knowledge in computer science of the non-computer science teacher is, I think you can rate it with a 1-star rating on the MS scale. It's almost nothing. Well, maybe the know-how using of an iPad or stuff, or social media or stuff, but there is, I think, almost no knowledge of any basics of computer science. They never saw maybe the program code or never coded anything like a small game and scratch themselves. So there's absolutely, I think, almost no understanding. There's the idea that computers work by is controlled by magic from nerds. On the other hand, we do have computer science teachers, and we don't have enough of them at the current point of time. We're putting a lot of effort in training teachers that are already on the job to qualify them, to get the knowledge and the abilities to teach computer science, which is far not enough. But as far as we do have so little time in our timetables, that's one effort. And even those teachers who are interested in computer science on the first day, some of them, they really start with zero knowledge. When you start teaching textual programming, you have to teach them how to, with the Alt key, where to get the open brace, where it's located on the keyboard. But if these are on the training on the first day, after the first day, they can code a little game. They start and they encounter, well, it's not done by magic. It's everything. It's based on easy principles. There's no rocket science in computer science, but it's a long way to go with them. The question is, how can these newly educated teachers teach AI? Well, it's a long way from zero to get to a point where you can teach classical computer science. But we also have a lot of teachers that come from, or some that studied computer science in university. And of course, for them, it's not a huge problem to deal with all the stuff and pages like on an internet, what's it called? AI elements of, the elements of AI page are great resources for those teachers who have the basic knowledge, and they can take it into their classes. They can take it into their classes and do something with students, but it's all based on the knowledge of teachers, and a teacher who has absolutely no knowledge when he hits those examples. I don't know where this might lead. I heard a story of some teachers who went to I think it's 1 or 2 years ago, went to a teacher training. Well, it was something like AI Unplugged. And they returned and I asked them, well, what did you do there? And they told me, well, we put some colored marbles in matchboxing and passed them around, but they didn't get the idea what this had to do with AI. So still, it's a great challenge.
Thank you very much. We got a question from the audience. And it's, as you mentioned, AI in data science is a highly interdisciplinary field, combining computer science, statistics, and domain knowledge. How do you think is it possible to get together all these competencies in school in order to gain a differentiated view on AI and data science from all these different perspectives? I can't really track exactly at whom this question is aimed at, so I just would give it to everybody here in our expert rounds. Yes, what do you think?
So I think Alexander Mittag would be the expert when it's about school, but I'm so free and just give my opinion on this point. So in school, you typically in many domains, you lay the foundations, yeah? When you teach other STEM subjects, mathematics, physics, and so on, you lay the foundations. And for many people, for many persons, that's it, because you learn a little bit physics or math in school or computer science, and then you do something else, yeah? But you take these basic things a little bit with you, more or less, yeah? And I think we cannot expect more from computer science. When we look at the hours Alexander Mittag showed us per week or per school year, definitely that's not enough. But nevertheless, I think it is simply not possible to teach what you start teaching at university in completeness in school. So I think this looking at basic computer science, AI algorithms, and data science, you would cover so many different things when you would do this on a technical level, that here I agree completely again with what Sanna said about project-based experiences. So you can I think when we make a curriculum, I think there's also some positive things about a curriculum, like thinking about what are the basic skills, yeah? But this should not be like 8 hours every school day, yeah? You could reduce this and give more room to projects. And I think in projects, you could at least show a little bit that you need what you learned in your basic statistics, which we have in school, maybe in combination with some machine learning algorithms. So I think it's a challenge. It's a challenge for everybody who designs teaching programs, like Alexander Mittag, for example. That's the big challenge we have to meet.
Definitely. Anybody of our other experts wanting to join in on that?
Talking about interdisciplinary AI and data science, this is one thing that I believe was the aim with the Finnish curriculum embedding ICT in all kinds of subjects. Why we call data literacy a literacy. There are many literacies, but if you compare it to reading and writing, the classical tools, then are writing and reading only taught by those teachers who teach like the mother tongue or German language or Finnish language. No, reading and writing are taught by all teachers from the point of view of their subject. Of course, this is not exactly a reality everywhere in the world, not in Finland with our embedded curriculums, but I think it is something worth really thinking about, like data literacy. Is it possible to include it in other school subjects, because that is a great way to bring through the point of interdisciplinary science.
Thank you very much. Mr. Mittag, what are your thoughts on that as someone who is actually developing educational plans? Can we implement data literacy and data science broader and overall in school education?
Well, for several years in the past, this was also a theme when people thought it's so important. If it's so important, just let it put in all subjects. But that assumes that the overall teacher has enough knowledge about what to teach. It's like, imagine just you would go and say, well, we cancel mathematics. It's so important. Just let mathematics is taught in every subject. And it would end up like me teaching Finnish. I know 10 or 20 sentences in Finnish, but not more. And I will never get a Finnish teacher, as hard as I try. And if you distribute the important parts of all everything, it's a dream, it's an illusion. and it would require way more educated computer science teachers than if you just put it in one subject and put one teacher, and this illusion will never come true. It's the hope for magic again, I think. We had this in Germany, and well, luckily the way went to, we established a subject. We just created that in grade 7. We created the optional subjects for some other reasons in 8, 9, and 10. That's the first step. And we hope to get a mandatory subject maybe in the next iteration of curricula that starts, but the idea of spreading it all around. Well, of course, on the other way, we'd say, well, reading and writing is taught by every teacher, but they all know how to read and they all know how to write because they encountered it themselves in school. But not all teachers know anything about computer science. So this is just a dream.
Thank you very much. Mrs. Reponen, you want to get in on that?
Yeah, I understand that like the challenge of somebody has to like have the responsibility to like whose responsibility is to like make sure that the basics are laid like correctly. And this is true with reading and writing, of course, as well. There are teachers whose like proficiency is like making sure that the reading and writing skills are like the groundwork is done right. But to add that, I still see that there's a lot of potential in, for example, open data movement. Like what if you introduce a data set that, for example, using the Gapminder tools created by Hans Rosling's foundation, and then peek at the data behind like the tool. It's not the same as laying the groundwork, but it is still introducing actual real-world data through an innovative tool that lets also those who are not data science professionals experience what different ways there are to present data.
Thank you very much for your input. At this point, I would like to get a look at our public questions. And what people decided on. So people think that AI is maybe a bit overhyped, but most people are actually convinced that AI can be used in a meaningful way in education to empower people. So that's nice. And I see we have like one person we have to convince otherwise. Maybe we get to that tonight or on a different occasion. But with this results, I would like to question into our expert round. What does it actually need to empower with AI in data literacy in education? Is there anybody who wants to jump in on that? Mrs. Schmid.
Well,
or Mr. Mittag.
I'll give it a start. Well, besides the topic of AI as a subject, talking about how AI works, how stuff works, I think AI is still a great way of assisted teaching, assisted learning apps. I myself, it's just an episodic study of myself. I think I myself learned a foreign language just using a smartphone app. And that uses very basic things of AI with Duolingo. And it's really a nice way to learn with that app. And the first day I was in a foreign country, it was actually in Denmark, and I learned Danish. And the first person I spoke to in Danish and actually realized I can communicate with a person, and I never spoke to a Danish person before, just using the app. And that really great ways of learning, because it's learning a language is on some level, it's just standard stuff. Whatever language you learn, you start with, hi, my name is whatever, and you really can't do this. And different people can do this at their own learning speed at different points. But I think another way, there's a great hope that maybe when students writing essays, there's some automatic scoring of their essays done by an AI. I don't know if this will ever lead to some success, or it will lead to students that really fast find out what to write to be scored in a great way by the AI. So that's like if you produce text by AI, to let them rank by the Google AI. So the one AI is writing a text that is read by another AI to get a good scoring on the page rank. And there are some things that get absurd, but I think it really in assistive teaching with apps and learning programs, adapting exercises, it can be a really, really great way. And I encountered it was a really success on my
own. Can you repeat the question? I'm not sure whether I got it.
Yes, of course. The question was how we can actually use AI in data literacy education to empower people.
Okay, in general, not focused on school, but in general, use AI. And so I think this is a little bit similar what I would answer like in my opening statement in a way. I think, without data literacy and basic ideas about what AI, data-driven AI mainly is about, I think future life will become, when you have no background there, I think it will be more and more problematic. Like, you know, when you look like years ago when elder person had to buy a ticket at an automaton or get their money by a teller machine or something, yeah. This was also an obstacle, and I think the obstacles will be less and less kind of visible, but they will be kind of invisible. So I think it's really important. But I was still thinking about things Alexander Mittag told before about, for instance, when you do AI unplugged, whether what you really understand when you do this, or what Sanna said about a purely explorative approach, which I think demands a lot from the teachers. I'm completely in favor of such an approach, but if you don't have a very, very skilled teacher in the topic as well as in pedagogic, this will be really a problem, because what I see, for instance, is for easy things. We have these unplugged games for basic computer science skills, and by the way, also for AI, basic machine learning, neural network, and because not all of AI is machine learning, also about heuristic search, and you could also make games about logic inferences. I'm sure about that, and I think we should do this also. I think when you start doing this and a teacher just reads, okay, we can do it like that, yeah, and has no background, terrible things happen. What I saw, for instance, as an anecdote, is we kind of had a game to searching in ordered or unordered lists. Yeah. And typically what you do when you work with children in primary school, you start with some experience in their everyday life. So, and typically what we do when we do this, we say when they are second or third grade, oh, you know, when you have your German book, you check out words. When you now want to know how to spell elephant, how would you look for this word? And then we use cards, sorted or unsorted, look at different search strategies, very, very free. And so one teacher who just looked at our material started with his own introduction, said, well, you all, I'm sure you all experienced in your life the problem that you didn't find your key. Finding a key in open space is a completely different algorithmic problem than finding an element in a sorted or unsorted list. And this is terrible, right? And so I could tell you tons of such anecdotes, and we kind of try to remember them and write them in boxes in your handbooks and say, attention. Yeah, don't do that. Yeah, so it's really educational for me to see what people can make wrong in teaching. So I'm sure I also make lots of errors in teaching, but so I think we need really to educate the educators to have a chance to do this right.
Thank you very much. We have a question for you. The question is, did your school students reach practical use of AI, which is more useful in everyday life than just proof of concept?
Practical use of AI. That's interesting point. So what would be an example? So typically what you do when you do a project is when you do machine learning, yeah, there are many domains for AI. Automated inference, action planning, game playing, where you also could use machine learning. But let's focus on machine learning. When you do this, you would do something like look at some data sets. Sanna already told us about that, and then maybe apply different learning algorithms and understand about how to test for predictive accuracy and so on. So you could do something like learning from your weather station. I don't know whether that's the right word. When you have a school project measuring temperature and different things, maybe use a microcomputer, use some sensors, and then you could use some not too complex machine learning approach to look for, can I predict temperature or CO2 or whatever. Yeah, you could do this. Is this what you mean with practical? Then yeah, okay. But I think many AI projects are in the making. So I have problems with practical use of AI, with the term. Yeah.
Thank you very much. Anybody wanting to get in on that or respond to that? Otherwise, I would move to the next question. Okay, then this next question would be for Mr. Mittag again, but also for everybody else. If you have a thought on that, please share afterwards. And I would like to know how can we actually make educational decision makers make aware of the need for quality in resources and training for AI and data literacy?
Well, if I knew the answer to that, I'd be very happy. I don't know. I think it's as I told before. I think the awareness in politics that this is somehow important is there, but as I enter with the chart, you saw the chart, you saw the little time we have for computer science. We saw the little time, and if you want to put some little time on that, like Schmid says, it's like brain surgery in 5 minutes. It's like if you do something like Europe in 5 days, you think that Germany is Oktoberfest and cuckoo clocks, and Finland is just saunas, wherever. And if you do the in AI on the same scale, you will never get the idea of the basic concepts between a rule-based algorithm and a real data analyzing-based algorithm. You would get the idea that a rule-based algorithm can be 100% correct in a certain scope, and a data-driven algorithm might maybe never be a 100% accurate by design, not by the error of the programmer. And I don't know, I think it could be a chance in the AI buzzword that politics gets to a point where you think, well, if we need AI, then we have to implement CS, computer science, as a subject first. And if we have some resources and if we have allocated the space and time to do all this, then there's also time for AI. But there's also a really hard decision. But if you look at the pie chart, you want to increase the number or the time of computer science. This means you have to decrease the time of other pies and to decrease of other subjects. And this is something that no one wants to do, because this is in politics, you do not have very friends, because if you look at the pie chart, then you have 99% of the subjects is non-computer science. So if you have the idea of decreasing that part, 99% of all teachers, well, they won't be very happy about the idea. So somehow we have to get the idea that in the 21st century we have to rediscuss that overall timetable. We have to reprioritize all the subjects we have, and maybe we have to decrease. No, I'm sure we have to decrease it somewhere, or increase the overall timetable at another year at the end. I don't know, but I think that's the only way. And as long as we do have so little time, there's actually no chance of really doing it right. And well, we could do it wrong, but that's not well the way I want to go.
Thank you very much. Mrs. Reponen, you want to join in on that?
Yeah, I'm just thinking, like, if you would look at the work of a teacher and compare it to some other job where you just have to learn new things and the task seems overwhelming, what do? You break it into smaller pieces. So I'm a little bit of a different opinion when it comes to the right and the wrong way to teach AI if we look at it as something that we can break into smaller pieces. If you're doing art and the art teacher doesn't have the skills and the means to like start doing like AI enabled art with the students, what if they grab an article about an AI piece that was auctioned at Christie's at a massive price, or if they look at a bot that ordered I don't know, weapons and drugs and a Coke machine to an art exhibition and start discussing like who's the author. That's already tackling an important topic in AI in a very small chunk. So I would promote this idea, like, does it have to be all or nothing?
Thank you. Mrs. Schmid, what do you think?
Yeah, so I think Alexander Mittag very much has the perspective of Fachlehrer, teacher in one subject, while Sanna has a rather broad view. And I just thought, for instance, when you look at physics, obviously you can talk about dangers of atom physics on a level where you don't need to have a lot of knowledge in atom physics. Obviously, you don't really understand Halbwertszeit and whatever. Sorry for the German term. But you have you can get some general ideas about the problems of nuclear waste. When you read, as Sanna just gave examples, maybe a discussion, a pro and cons, stuff like that. Yeah. And I think just to reconcile these two opinions, I wanted to do this. I think both are really important. I think the subject teaching is important. And I think what I think sad when I look at German STEM teaching, at least what I see in Bavaria, in difference maybe to the Northern Europe countries, is that we also teach physics more like learning by heart in a way. So I'm not good in physics. I had not physics many years. But my impression is, if you would do what we have in AI, a long tradition in qualitative physics, like trying to observe and understand a phenomenon, and then in a next step learn how to grasp this phenomenon with mathematics, yeah, I think this would be helpful much more than teaching formula. Many of the students will just apply and never understand. And I think this teaching style is basically what Sanna propagates, also for computer science. Obviously, you need to know your basics. Without knowing the multiplication table for the numbers to 10 by heart, it's hard, yeah. And so you need to start with the basics, and the basics might be on different levels, depending on how far you want to go in the science, but you need them. But on the other hand, you need this encouragement to think. And I think teaching like that, it's much more demanding, and teacher education would be much more complex to do it like this, yeah.
Thank you very much. Considering the time, I would come to my last question. And I would like to know, can we break free from all the empty buzzwords and hype regarding AI and data literacy? And what has the future in store for us? What do you want to see in the future of education?
Who should start?
Maybe, do you want to go?
Yeah, we can give Sanna the last word. Yes, so I think that education is very much, as I just gave with the example of physics, about understanding, yeah. About the ability to learn knowledge and skills in such a way that you can transfer knowledge. And I think, therefore, we have a big chance with data literacy and computer science education, as well as AI education, maybe as part of computer science education, to school computational thinking. Algorithmic logical thinking would be the more conservative term. Seymour Papert propagated this back in the 1960s. So I think we have a big chance when we introduce this in schools and help to make, as a remedy against the digital divide, for instance, and also, to keep as much, maybe more people interested in studying computer science and becoming AI experts.
Thank you very much. Mr. Mittag, what do you say?
I would really look around to have more time to do things. If you look at other subjects, think about physical education, swimming. One, of course, we could talk about water. We could about the chances and the risks of swimming and not swimming. But what you actually do, students do swim. They do play football and art. They do paint things, and that's the way you learn it. And in computer science, you learn computer science by playing around with things, by playing around with Scratch, by creating games, by playing around with things, and that all takes time. If you all have a look at the great AI stuff, elements of AI, you can play around with things, but this takes a lot of time. You can't do an element in AI in 90 minutes. You can't do it in 2 hours. You can't do it at a weekend. It really takes time, and I'm really looking forward to time to have the time to play around with things, to experiment with things in a way that allows you to have enough time to make, well, errors or mistakes. But we know everyone who's in computer science, who's a programmer, we have a very special relationship to errors, because we make them all day, we make them all the time. So if we make an error, it's not something as a catastrophe or whatever. It's just before everything works, 99 times before it does not work. And so this is a really change in the mindset. If you play around with things, they won't work the first time. They won't work the second time. And this setting takes really a long time. I'm looking forward to this. And I think this would be a great way to teach AI or teach computer science. And this is a great way to let students make themselves their own way into AI by playing around with stuff.
Thank you very much. I would say Finland has the last word on that.
Thank you, very polite. And thanks, by the way, for this conversation. This was actually a debate, and I loved it. I've had a good time in this session. In AI education and as a result of AI and data science education, I would like to see maybe more angles for different kinds of people. Like if you're not into like, you know, the traditional way of learning, then you might have a different way to get your hands dirty and get going, because the same kind of learning doesn't work for all. But as an outcome, I would of course like to see more people with like the guts and the vocabulary to say what kind of technology they want to use in the future and go and develop it if possible. And yeah, I would like to see as an outcome both students and teachers who are not too afraid to get their hands dirty, or who are not too worried of breaking things, or not being too proficient enough to try, at least.
Thank you, and thank you all so much for being part of this WebTalk. I think we can conclude that AI and data literacy in education is needed, and we need further deeper education on that and also the development of it. And yeah, we still have a long way to go. But at the same time, I think it became really clear that we have a lot of very passionate experts behind it. So I would say I'm very excited for AI and data literacy in education, because people with a lot of heart and passion are behind it to further it in our society. Yes, thank you so much. And everybody in the audience, I wish a great evening. Goodbye.
Goodbye. Thank you very much.